Okay, there is another type of angle that kind of goes along with supplementary angles, okay? Supplementary angles do not have to share a side. Okay, supplementary angles can be two different angles in two different places. They just add up to 180. But what if two angles share a side like this, and they make us, oh gosh, I cannot draw a straight line straight up or anything. Okay, so what are those called? Does anybody remember what those are called? If they're right next to each other.
It's on the tip of my tongue.
What are they? Yeah.
Is it collinear?
They're well, they're not quite collinear. Collinear would be all on one line. Yes.
Are they linear pairs?
They are linear pairs, okay? They make a line, linear pairs. So it's a pair of angles that make a line. It's a pair of angles, they share a side, and they make a line. So that's why they're called linear pairs. What is the sum of a linear pair if I add the two together? Yes.
180.
180. So this is kind of like a supplementary. Linear pairs also add to equal 180 degrees. Okay. Sure. Okay. So that's something else that we know. Okay, so those are about angles. The first part was about triangles and what we know. Second part was angles. Okay. What do we know about line segments? Oh, there's one other thing about angles. Okay. What am I showing there? Yes.
Bisected angle.
Yes, a bisected angle. So if an angle is bisected, then what do we know about the two angles?
They're equal.
Yep, two angles made are equal. So that's another thing that we really know. The last one's just about a line. It's very similar to this. If a line is bisected, what do we know? There's actually quite a few things we know when we bisect a line. What is it that we know? Anybody know? Yes.
Well, it's split into two equal.
Okay, it made two equal points. Or these are cold. I don't think they're warmed up to using it. Two. Okay, this is ridiculous. There we go. Two. Can you guys see that? Two equal parts. Which then we call, which gives us the midpoint. Okay, so it's two equal parts. We have the midpoint. What else do we know when we bisect a line? Yes.
Makes two equal angles.
It actually makes. So let's think about it. So when we bisect the line, we come straight down like this.
Oh, bisect. Okay.
Yeah, so we're bisecting the line. So what do we actually get here?
4 equal angles.
4 equal angles that are what?
90 degrees.
That are 90 degrees. So when we bisect a line, that line that bisects the middle is perpendicular, so there's 4 90-degree angles. So the line bisected with the bisector form perpendicular lines. Which means they are all 90-degree angles, okay? So those are some of the things up to this point. Now, I'm not going through every single one, but these are some of the major ones that we use over and over and over again. So it's good to have a list. I like to give you kind of a cumulative list every once in a while because that way you can go back and see it in one spot in your notes and you don't have to page through a whole bunch of notes, okay? So I try to give you the ones that we've been adding all along, okay? So today in 5.2, we're specifically looking at a new situation. And we're going to find out what does that, we're going to define something, and then we're going to find out what does that do as far as what are our things that we can determine. Okay?
Can I take?
Pardon? Sorry, what? Oh, I'm sorry.
Oh, sorry. I got it.
Okay. I'll look for a different pencil or a pen that works better. Okay, we are going today to look at, in 5.2, exterior angles. Okay, so just from the word exterior, what do you think that means? I should say exterior angles of a triangle. So just trying to define this, and I know some of you defined it because you took notes from the book, but what does exterior mean? Yeah.
Outside.
Outside. So if I'm talking about exterior angles of a triangle, it must be something to do with angles that are outside the triangle, okay? And that's exactly what exterior angles are. Exterior angles, I'm trying to find different markers here. Let's see. Try this one. Exterior angles are angles that make a linear pair with one of the angles in the triangle. Okay, so it makes a linear pair. So if I look at a triangle like this, okay, we make a linear pair with an angle inside. So I have angle 1, 2, and 3. It doesn't matter how we draw our, but those are the 3 angles in our triangle, okay? So what we can do is we can just extend one of the sides to make a line, and that will give us an exterior angle. So let's look at it. If I look at, I can extend that line. It's supposed to be nice and straight, mine's maybe not, okay? But what did I do? I extended this line, and then this is the exterior angle because it's the angle that's a linear pair with one of the ones inside. So this would be called the exterior angle. That is one exterior angle, okay? If you were to draw all the exterior angles, how many would there be? If I was to go through and draw all the exterior angles, how many exterior angles would I actually have? 6? Everybody's kind of going, 6? I'm guessing, I'm not real sure. Why do you think there's 6, David?
Well, I don't even know. Wait.
Oh, that, Come on,
Well,
you
it's
stated
like, If you
it,
got one right here,
yeah.
then you could have one coming down off this side.
Oh, I could
too.
have one here
And then
too?
that can happen on each side. which is
Oh,
six.
yes, there are 6. There are 2 exterior angles at every angle, okay? So we could find this one, okay, which is an exterior angle here. Do you notice anything about the 2 exterior angles there? Just look at it for a moment. Those 2 exterior angles at point or at angle 3. What do you notice about them?
Are they vertical lines?
They are vertical angles, okay? So this exterior angle and this exterior angle will actually be equal to each other. So the same one at the 2 different ones at one angle. So if you have 2 exterior angles with one angle in the triangle, then they are vertical angles and have the same measure. Okay, that's kind of an interesting thought, but that's really what it is. So this one would be congruent to this one because they're vertical angles, they're both exterior angles with 3. And if you actually looked at it, this one would be the same. That little tiny one that forms out here with those 2 exterior angles will be the same as 3 because it's also vertical. Because if these 2 are equal, then these 2 have to be equal. It's always vertical angles like that with 2 lines, okay? So we could draw, if you wanted to continue to draw them, this line out, that line out. Again, this is an exterior angle. This is an exterior angle. These 2 again are the same size. They're not the same size as those, however. Okay. And again, we could draw it out this way and this way. These are the exterior angles, so we put 3 across. So, total of 6 exterior angles on a triangle. So you can always make exterior angles on your triangle and see things that you can see there, okay? Can anybody tell me, and look at actually of the definition of exterior angles, and tell me if I know anything about the interior angle and the exterior angle that's together, what if they maybe equal?
Wait, did you want the definition?
No, I already gave the definition.
So what the interior and exterior angles?
Yeah, what would they equal?
360?
No, not just one pair.
Okay.
One set of the interior angle, what would it be?
180.
180. They make linear pairs, right? We define them to make linear pairs. If they make a linear pair, we know that a linear pair always adds up to 180 degrees. So we can say angle 3 plus the exterior angle, and I'm going to call it 4 for right now. Angle 4 have to equal 180 degrees. So this is the interior angle plus the exterior angle, and defined the interior and exterior ones are linear pairs, they're right next to each other, and they must equal, because they're linear pairs, they must equal 180 degrees. Okay? So that is some things that you can gather about exterior angles. Those are some of the things we can look at and see. Okay? Now they give you an inequality. We're going to also look at something else in a minute. We're going to keep that part there. Okay? And I'm going to simplify this drawing up here so there's only one exterior angle, okay? Because I don't want to, it's pretty confusing at the moment. Okay, so I'm going to go back to have just one exterior angle. So this is angle 1, this is angle 2, this is angle 3, and I have this exterior angle right there, so we'll call that 4. Okay, does that make sense? So I'm redrawing it without all those pictures so we can look at it a little better. Okay, there's a theorem, which is really stating a fact, okay, about inequalities here, about angle inequalities. What do I know about angle 4 compared to angle 1 and 2 in this triangle? What do you know? Anything? The size of angle 4 compared to angle 1.
Always bigger.
It's always bigger. Angle 4 is always bigger than angle 1. Okay? So the exterior angle is larger. Now I'll have to ask this. Is angle 4 bigger than angle 2?
Yes.
You're guessing yes, right? Okay. Is larger than both of the, I forgot how they say that. Remote interiors. That's it. Remote interiors. I was going to say the ones that are far away. Interior angles. So yesterday we talked about all those inequalities. This is an inequality that we can actually prove. I'm not going to go through it. Well, in a minute we will. Okay. So what this really says is basically angle 4 is going to be larger than angle 2, and angle 4 is going to be larger than angle 1 because the remote or the exterior is always bigger than both of the remote interior angles. Okay, so that's what we can find out from that. Now I'm going to ask, how could we show that? How could we kind of show that that is true?
That's what's true.
That the exterior angle is always larger than both of the remote interior angles. How would we figure that out? And I'm not going through the proof that somebody used. I'm actually wanting to use something that you guys already know. Yes?
You could use a protractor.
We could use a protractor, but that would be kind of inaccurate. We're going to try to prove it generally. Okay? So I want you to give me, so tell me a little bit about this. Angle 1, angle 2, and angle 3. Know anything about those three? Yes.
Together they equal 180.
Yes, they do. So
And then one interior angle and an exterior angle equals 180.
yes.
So that means
Okay, so this is what we know. We know that angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. That's because those are the sum of the angles in a triangle. Okay, so we know that. We also know that angle 3 and angle 4 equal 180 degrees. Okay? So if that's true, if angle 3 plus angle 4 equals 180, and angle 1 plus angle 2, okay, what is angle 1 plus angle 2 actually going to equal?
Less than 180.
Is it going to be less than? Let's see. If angle 3 plus angle 4 equal 180, and if I add angle 1 and 2 to angle 3, I also get 180. What can you say about angle 1 and 2 and angle 4?
They're equal.
They're equal. Okay? Because if I add angle 3 here to angle 4 and I get 180, I could replace angle 4 with angle 1 and 80 and angle 2, and I'm adding it to 3. So angle 1 and angle 2 must equal angle 4. Otherwise, that is not true. That statement up above is not true. So you can see that they are that way. Now, if angle 1 plus angle 2 equals angle 4, what does that tell me about angle 1 and angle 2? They have to be less than angle 4, correct? Because if you have to add them together to get angle 4, each of them has to be less, because we can't have a 0-degree angle. Okay, we can't have a 0-degree angle, so one of them will not be 0. So therefore, this is true. Okay, because angle 4 is equal to the sum of them, so it has to be equal to it. Okay, this is actually the thing that we can really use, is the fact that if you know angle 4, you know that's what 1 and 2 make. Okay, you also know what 3 is. Okay, because if you know this one, you're going to know what 3 is, because it's a linear pair. If you know what this one is, you know that these two are going to at least equal that. Now, we can't figure out exactly what 1 and 2 are, but at least we can figure out that they're going to equal that exterior angle. Okay, so that kind of gives us some information in there. Or if you're given 1 and 2, you can actually tell what this is, and you can get that, which you can also get from doing the sum of the triangles. So those are some things to look at. So we're going to play with exterior angles today. Okay, so we're going to look at the exterior angles and see what we can find, out about different situations using that information. Okay, so we're not going to take